Hey, what's up? It's easy, so I've done it before, but whatever. Leetcode 3069. Distribute elements into two arrays. You're given a one-indexed array of distinct integers. Why do they do that? Why can't they just be 0? Okay, whatever. Nums of length n. You need to distribute all the elements of nums between two arrays, array 1 and array 2, using n operations. In the first operation, append nums1 to array 1. In the second operation, append nums2 to array 2. Afterwards, the ith operation, if the last element of ARR1 is greater than the last element of ARR2, append nums I to ARR. Otherwise, append nums I to ARR2. The array result is formed by concatenating the other. Okay, fine. Got it. Got it. So ARR1 equals nums dot pop 0, right? And then ARR2 is nums dot pop 0. And then for I in nums. Okay, so if the last element is greater than the last element. So if ARR1 last element is greater than ARR2 last element, then append ARR1. ARR1 dot append I, else ARR2 dot append I, and then we concatenate. Okay. So little dorky there. So hey, come on. I hate it when it won't let you select. Okay, let's see here. Problems, daily problems. Okay, boom. Okay, let's see. Oh, hard, huh? Well, this is tomorrow's problem, so whatever. You're given a one-indexed array of integers nums and length n. We define a function greater count such that greater count ARR val returns the number of elements in ARR that are strictly greater than val. Okay. You need to distribute all the elements of nums between two arrays ARR1 and ARR2 using n operations. In the first operation, append nums1 to ARR1, and the second, append nums2 to ARR2. Afterwards, if greater count ARR of nums I is greater than greater count ARR2 nums I, append nums I to ARR1. If greater count ARR1 of nums I is less than greater count 2 ARR nums I, append nums I to ARR2, and if they're equal, append it to the array with the lesser number of elements. If there's still a tie, append nums1 to ARR1. The result is formed by concatenating the arrays ARR1 and ARR2. For example, if, yeah, I don't need an example, I got it. Okay. 10 to the 5th. 10 to the 5th n log n should work, right? I think. Trying to think here. If we just maintain a sorted list at any given point in time. Okay, let's see here. So ARR1 equals nums dot pop 0, ARR2 equals nums dot pop 0 ARR sorted ARR1 sorted equals ARR1 dot copy and then ARR2 dot copy. Let's make sure that it really copies. Equals 99, print ARR1 and print ARR1 S. Okay, all right. It is sufficient that they are separate. So, I hit the wrong thing. That was my fault. Okay. So let's see. So we define a function such that greater count returns the number of elements that are strictly greater than val. The number, okay, so def, let's just, whatever, ARR and number, I guess, I don't know, greater count, number of things that are strictly greater than. So I think index is going to be bisect right of ARR of n, and then it's simply going to be the length of ARR minus I think. Let's see. Greater count naive is going to be return the sum of 1 for I in ARR if I is strictly greater than n, right? And then we'll say def both ARR comma n, and we'll say value 1 is this, and value 2 equals naive, I don't know why I hesitated, and then assert v1 equals v2. Okay. All right, let's implement this nonsense here. So I don't know. This isn't triggering my, it feels like a busy work thing. So for I in nums, right? If both ARR1 sorted comma I is greater than both ARR2 sorted I, then we're going to have ARR1 dot append I and insort ARR1 sorted comma I, like that, and that is the first condition. Okay, if it is less, okay, this isn't going to work, so let's say v1 v2 equals that, and this is v1. Okay. Otherwise, if v2 is lesser than v1, it's almost the same. Okay. Otherwise, they're equal. There's nothing else that they could be. Else if length of ARR2 is less than ARR1, length of ARR1, one with the lesser number of elements, right? And then if there's still a tie, then it goes to ARR1. Or if it has lesser elements. Either way. Yeah. Let's make sure we didn't do something stupid. 1, 2, 2, 2, 2, 1, 1. Okay, we're good. And then simply return ARR1 plus ARR2. And let's see if this works. None type and none type. Okay, everything passes. Let's get rid of this shit. Well, hold on. Wrong answer. Now that, I was not expecting that to happen. Okay. Use test case. So it's not this. Let's see here. Boom, boom. Okay, so print, well, hold on. Print ARR1 ARR2 and then print V1 and V2 and I, right? So let's see what is going wrong here. Okay, 2. Okay. So things strictly greater than 2 is 38. So V2 is indeed bigger. If V2 is bigger, then did I read the problem wrong or something? Okay. So it's the one that is smaller that it gets appended to. So if V1 is, I have it completely backwards. How did we pass as many as we did? All right. So V1, if greater count is greater than, no, it wasn't backwards. It wasn't backwards. It wasn't backwards. So if V1 is bigger, this is V1, then append it to array 1. Okay, so we're back here. So V2 is definitely bigger than, oh God. I knew something was wrong. I knew something was wrong. Okay. Okay. That's fine. I just screwed up. All right. It worked. Okay. Sounds good. See ya.